How precious is your presence, Father. Please guide us. Geometry students, grace and peace are with you, and God is for you. So then who can be against you? I trust this will be a useful geometry practice quiz for you coming up tomorrow. I'm going to go ahead and start with the first one, which says, since we are continuing to study central features of triangles such as perpendicular bisectors, we also have angle bisectors, which I don't have down here. It is wise for us to ponder the importance of the heart, getting to the center of anything. Write a scripture which gets to the heart of this. This would be our great scripture from Proverbs 4. And this one, I'm sure you know it. It says the following. Keep your heart, and I trust you and I will do this. Keep your heart with all diligence. For out of it spring. I was going to use the wrong word. Spring, the issues of life. Go ahead and rehearse that with me. Say this with me. Keep your heart with all diligence, for out of it spring the issues of life. Let's keep that in mind. And then number 2 says, write 3 facts about the mid-segment of any triangle. So the first one I told you about was that it is a segment joining the midpoint. The midpoint of 2 sides of a triangle. Of a triangle. So just to give you a visual here, if you have a triangle like this, your mid segment would be a segment like this, where this is a midpoint, and this is another midpoint, as evidenced by these check marks. Another feature is it is parallel to the third side. It is parallel to the third side. That means the third side of the triangle. And thirdly, it is equal to 1/2 of the third side. So it's parallel to the third side and equal to 1/2 of it. I'll just leave it like that. I trust you have that. So if the third side were 50, the mid-segment would be 25. If the third side were 30, the mid-segment would be 15. So here we're going to take a look at these problems concerning the mid-segment. I trust you got this really, really well. And I'll just mark these. I won't work the numbers out. I trust you got it. But the mid-segment here is given that MS is a mid-segment of triangle ABC. What does that mean? It means that point M is the midpoint of segment AB. Point S would be the midpoint of segment CB. So that means BS and CS would be the same. This segment here, mid-segment, is going to be parallel to the third side and equal to 1/2 of it. Alright? So this, I'm going to trust that you know how to work this. I'll just do the setups really. This mid-segment, if you take 2 times the mid-segment, it will be equal to the third side, which is 2x plus 24, because as was said, the mid-segment is half of the third side, so twice the mid-segment will give you the third side. Okay. What I did not emphasize a lot was that since these two are parallel, and I could just kind of make these into lines, so MS, if I make it into a line, and AC, I make this also into a line, and this AB, if I could make this like a transversal, well, this angle would be congruent to that angle, because when parallel lines are cut by a transversal, which is what AB would be, then corresponding angles are congruent. And that's why 8y would be equal to 40. You could work that out to find y. Alright? So that is some good review for the mid-segment. Let's move into what is called now the perpendicular bisector. And number 4 says complete the following. And it reads, if a point is the perpendicular bisector of a segment, then you could say then it is equidistant from that segment's endpoints. Say that with me. If a point is on the perpendicular bisector of a segment, it is equidistant from that segment's endpoints. So, very simply, we're looking at that as a segment, and this as a perpendicular bisector of the segment. Then any point on this perpendicular bisector, let's just choose point P, it's going to be equidistant from the endpoint. Okay, so that would definitely be applicable here in finding out what x is, where it says find x in the figure. Okay, so you'd go ahead and you just set it up and say, oh, this point O is on the perpendicular bisector of GD, so therefore it must be equidistant from the endpoint G and endpoint D of this segment. That's why 7x minus 8 would have to be equal to 2x plus 32. And you can work that one out again for practice. And here comes a little bit more on the perpendicular bisector. Number 6 says C is the circumcenter. And I told you in class that the circumcenter, C, is the point of concurrency, or the point of agreement of all the perpendicular bisectors. So when you see perpendicular here, this has to do with perpendicular bisectors. Perpendicular bisectors of segments. That's all three segments of the triangle. So here's one perpendicular. It shows perpendicular, but you can actually put the bisecting feature in. Here's another one showing the perpendicularity, but you have to put the bisecting feature in because it's not marked. So if this is 16 from Z to D, you know it's going to be 16 from G to Z. Finally, the third one comes, and this also, if it's perpendicular here and you see circumcenter, then you know you have a bisecting aspect to it as well. Alright, now here's what I told you on the other side. If a point is on the perpendicular bisector, it is equidistant from the endpoint. So GD has got to be the same as GO. 1, 2, 3, 4. 1, 2, 3, 4. Again, if a point is on the perpendicular bisector, it's going to be equidistant from the endpoint. So this point C would be equidistant from point G and also point D. So we have 1, 2, 3, 4. So this tells us quickly that if this is 20 from C to O, and this must also be 20. And in this one, they want us to find CZ. CZ is this, which is like a leg of this right triangle here, right triangle GCZ. So let's take a look at it. This right triangle or righteous triangle is such that we can employ the Pythagorean theorem. C squared equals A squared plus B squared. And when you look carefully here, you'll see that the C is the longest. It's the one which is across from the right angle. So that's going to be your C. 20 squared equals 16 squared plus x squared. X is the CZ. So 20 squared would be 2 times 2, 4, and then 2 zeros, so that's 400. This is going to be 256 plus x squared. Subtract 256. We get 144 equals x squared. And we take the square root of both sides. We have 12 is equal to x. X is equal to 12. Alright, now we're going to transition over to something else which is called not the perpendicular bisector, but the angle bisector, evidenced by the fact that this small angle is the same as this one. So this ray is an angle bisector. At any point on the angle bisector, namely let's say this one, is going to be equidistant perpendicularly from the sides of the angle. So this must be the same as this. And that's why the setup here would be 9x minus 17 equals 5x plus 7. So that one you can work out to find x. And finally, this one, if the incenter, when you see that word incenter, that should remind you of angle bisector, angle bisectors. So you said, what about it? Well, we have 3 of them. One is here, as evidenced by this angle being the same as this one. Another angle bisector is here, because this angle is equal to this one. And the third one is here, and they all meet right here, which is called the incenter, because you can actually draw a circle inside of the circle using this incenter. Now, here's what I think I mentioned before, that any point on the angle bisector is going to be equidistant from the sides of the angle bisected. So equidistant from NM and OM. Similarly, this point here, F, on the angle bisector here, is going to be equidistant from this side and this side. So that's why FT is going to be the same as FK is going to be the same as FH. And if we want to find FK, he asks us to find FK. FK is the same as HF. So we look at this triangle here, we can use the Pythagorean theorem, and it says 5 squared is equal to 4 squared plus this, which is x squared, and you just solve